Welcome everybody. This is going to be our lesson, our introduction to arrays. Woohoo! We made it! We got to arrays, which are one of the cooler tools for computer science, for doing for programming. An array it sounds complicated. It's a word you probably haven't used before, but it really is nothing more complex than just a list. It's a list of stuff. It's so in programming typically, and in Java and most other languages, if you're gonna create a list of things, you're gonna want to make your list be all the same kind of thing. So for example, like if you're going to a grocery store and you want to make a list of all the things you want to buy. When you go to the grocery store, you're gonna, write down a bunch of groceries. So all those things are the same kind of thing. They're all grocery items you buy from the store. It wouldn't make sense to put down on your grocery item list, do homework for math class or something like that. You wouldn't put that down in that list because that's a separate kind of idea. And so you do the same thing in computer science. You don't want to group things that aren't the same kind of type together. And so the data structure, the thing that holds a bunch of elements that are the same kind of thing, numbers or words or characters or so forth, it's going to be called an array. So that's what we use in programming. Okay, so what is it? Well, even more detailed. An array is an indexed structure. So it's indexed, meaning there are addresses or ways to access each of the items in the array. It's a structure, meaning it holds a bunch of stuff that holds multiple values of the same type. Okay, so these are kind of the key pieces to what makes an array. It's indexed, it holds multiple values, and they're all the same thing. Okay, so it's not going to hold numbers and strings. It will just hold numbers, or it just holds strings and so forth. Okay, so a picture of what this might look like is usually people write arrays with a row of boxes. So you've got a bunch of boxes here, and each box has a number. You can think of the number as an address. Like how would you get the data that's at the address of 5 or the address of 9. So this is telling you where that piece of data is. And then the thing that's inside that box is going to be an element. Okay. So there's a bunch of terms we're going to get to on the next slide, but you can kind of see them right there. We have indices, which are each of those numbers telling you where the item is, and then you have the elements that are inside each of those boxes. This should sound a little bit familiar. We've been dealing with stuff this last couple weeks where we've been looking at an indexed structure that holds multiple values of the same type already. What can you think of that has a bunch of things at indexes that are all the same kind of thing? Strings. So strings also has that same kind of behavior. In fact, a string is really just an array of characters. It's just got a bunch of characters in sequential order. So it is an array, but it's got more stuff going on. So strings are a little bit different than arrays. So what's different about arrays versus strings? So a string, unlike an array, is an object, and we haven't talked a ton about what objects are, but objects have a special meaning in programming. But it just has an array of characters as its data. And so it's going to have some more things. There's more tools. What makes an object different from an array is that it has methods that you can call on a string. So you can access the string's length. Well, you can do that actually with arrays too, but you can access the string's length. You can access the substrings of it. You can access a uppercased version of it. So you can do these things. You can do these methods with strings that you can't do with arrays. So that's basically you've got all these methods you can do with a string, and an array doesn't have any of those tools. It's really just a plain vanilla list of things, okay, without too many methods. We'll find out later that there is a utility class that you can use that Java's created for doing stuff with arrays. Like it does stuff like sorting the array, and it can give you copies of the array, and it can do other things with the array. But it's its own special class, and it's not something that you call directly on an array the way you would do with a string. So unlike strings, arrays do not have any methods, and strings have a bunch of methods. So that's the difference between these. Objects have methods with them. Arrays aren't really objects. They don't have any method. Okay, so here's some array terms. Now that we've kind of cleared up, strings are very similar to arrays, but they're not. They're objects. Now we're going to look at some array terms. So what are some special terms about arrays? So each piece of data, so an array is a list, each piece of data in that list is called an element. So you often hear me say the element at position 5 or the element at index 2 and so forth. The element is the value that's at that location in the list. Each element has a non-negative integer assigned to it called an index. Okay, so that is that address. This is saying where is the element. So this is an address, and you know there's only one element at that index. It's telling you how to find the thing that's in that index. Okay, and then an array has a length, which is a positive integer specifying how many elements there are in the array. So we have a length, we have element, which is one of the items, so this is one item in the list. The index is the address, the length is how many items. And it's going to be a positive integer, right? You can't make a list with no items in it. You can't make a list with a negative number of items in it. You know, it could be something like 5 or 10 or 100. That's going to be how many elements there are in the array. Now, one thing to remember is that arrays are 0 indexed, and so just like strings are, right? They start at 0, and so indexes are always they always have to be between 0, less than or equal to, and less than or equal to length minus 1. So that's those are going to be valid indexes for an array. You can't access things that are at indexes that are length or greater, because those don't exist. There's no items there. And you can't access things that are at negative indexes. Those are illegal indexes as well. Okay, and Java will catch those for you and tell your program to stop if that ever happens. Okay, which is a good thing. You don't want to try to access things that are off the ends of. Okay, so some syntax for how do you build arrays? So syntax for declaring an array. The new thing here is the brackets. Okay, so you put 2 brackets, a left and right bracket, after the type of data that you want this list to hold, and then you specify the name of the array. So what do you want to call this array? So and then the syntax for initializing, how do you give it a value? Because an array needs to know how many items there are. How many items are you going to hold in the list? You would say the name of the array equals, and now this is a new word. We've seen this before. It is a new word. It's the word new. We've seen this before another time. If you think back, we've used new one other time, and that was when we built scanners, right? When we built scanners, we used the keyword new. Turns out when you build arrays, you also want to use the keyword new, and this is going to go ahead and create space for the array in your computer's memory. So new type bracket size bracket. So that's how you initialize an array. And so this size has to be a positive number, positive, okay? And that's going to be how many items are in your array. Once you've built it, you can't change that number. It's going to stay that size the whole time. If you create a whole and these guys match up, those types have to be the same type. It doesn't make sense to declare a type of a bunch of strings and then make an array of integers. Like, that doesn't make sense. You would have, those need to be the same. So one more thing about the array is once it's been constructed, you can't change its size. It's stuck at that size forever and ever and ever. If you wanted to make a new array that was bigger, you would have to, so say you filled up your array, you've got your list is too big, you need to add another item on. You actually have to go ahead and say, okay, make me a bigger array and go copy every value from the old one into the new one. And that's the only way to make an array bigger or to change its size. So once you've created the size, make sure it's big enough to hold all the things that you need it to hold. Otherwise, you're going to have headaches because you're like, well, I need to add another item to my list, but there's no more space. So a good way to think about it is make sure it's large enough to hold all the items you need to hold. There's another data structure that we'll look at later for dealing with resizing. For something that's, if you want it to be able to get bigger, and you don't want to worry about that restriction, then there's another thing that we can use for data lists that you don't know how big they're going to be. So some examples of declaring and initializing arrays. Something like this. Int bracket bracket numbers is the name. So we have, I'm going to use some colors here. So type I'll do in green. Int is my type. So you see the type over here again. And then we have, let's do blue. So my name is numbers. And then we have that keyword new. And then our size is over here. Let's use orange. So that size is 10. Okay? So int bracket bracket numbers declares an array of integers called numbers equals new int bracket 10 bracket. And that's going to set aside space for an array of 10 numbers. String bracket bracket names equals new string bracket 6 bracket. That's going to make an array of 6 strings. So if I wanted to hold 6 of my friends' names in a list, I would use an array like this. Okay? So the only difference between the one up above and the one down below is that the type is different, and they're going to make arrays of different sizes. Okay? There are a couple other distinctions between these, and we'll deal with between these two kinds of arrays. There's actually a little bit more funkiness with the second one than there is with the first one, but we're going to bump up against that later, so don't worry about that for now. Okay, so what happens when you do this? Well, when you write this line, int bracket numbers equals new int 10 in brackets, what happens? Well, it's going to go ahead and initialize everything in that array to 0 or the equivalent thereof. So there's several kinds of 0 basically. So for example, if I had an array of numbers and I said I want 5 numbers and they're all integers. So I made my int array, and what we end up doing is giving us space for 5 numbers, and the kind of name is numbers. These are our indexes up above. So these are the indices. And what are the things below? Those are the, okay? So we are auto-initializing this array, this list of 5 numbers to 0, 0, 0, 0, 0. Super useful, right? Well, we're going to figure out how to access and change these in a little bit. But for now, this is what happens, is you get space for 5 numbers, and they're all starting off at 0. If you did this with an array of doubles, you could do that as well. Well, what's it do for doubles? It's going to set them all to 0.0, which is the equivalent of 0 for doubles. You know, it makes sense, right? If it's going to be a 0 for double, it's 0.0. And if we were to do an array of booleans, what would the equivalent of 0 be for that? Well, it would be false. So everything gets initialized to false if it's an array of booleans. That's basically the 0 for a boolean. The other, a 1 for a boolean is true. 0 for a boolean is false. And if you make an array of strings or any other object, we'll talk more about what objects are, but if this is an object here, then they all get initialized to null. All right, and this is something funky. It's not a string. There's no quotation marks. Null really means that it's not there, that there's no object there. And we'll talk about null a little bit more on the next slide. So what is null? So we're going to look at it more in depth when we talk about when we get into building our own objects and what our objects are exactly in programming languages. But for now, what you need to know about it is that null means no object. It means that there's nothing there. And it's a special value in Java. You can always create an object or create a string and set it equal to null. And that's basically saying that there's nothing there. It's not an empty string, which is an actual, there's something there with an empty string. Null means that there's no object there. The one thing you need to be mindful of when you have null, when you've got things that are null, is that you can't call methods on those. So anytime you try to call a method on a null object, then you get an error. Okay? So here's an example of what I mean. So suppose we declared a string my name and assign it the value of null. So now this is fine. It's fine for us to do. String is our variable, or is our type, is our object type. My name is the name of it. Null is saying there's nothing there. There's no contents. You can imagine it's like saying, it's similar to saying my name, just declaring it, but not actually giving it any value, okay? My name has no value. It has no contents. It's null. So you're going to get an error if you try to access its length. If you tried to print out the length of my name, this would throw an error. And the reason why it throws an error is because there's nothing there. And so it's not that it would give you 0. It says, I don't know what the length is. And so it just breaks. It just stops and it throws what's called a null pointer exception. Because it goes to try to find what my name is. It goes to try to find that string. And my name is just null. There's nothing there. And so it says, well, there's no length. There's nothing here. There's no object. And so it throws an error. So you can't call methods on objects that are null. This might happen if you initialize a string, or initialize an array of strings, and some of them get initialized and some of them don't. Some of them, if they're all set to null, or if some of them are set to null and you try to get their lengths, you're going to run into a null pointer error. Okay? So just be mindful of this, that don't freak out if you get a null pointer error when you're trying to loop over an array of strings. It's probably because some of them didn't get initialized. Okay, so accessing, modifying elements of an array. So we've built our list. We've got how many things there are in the list. So how do we start to actually change things in our list, and how do we see what's there? Okay, so this is accessing and modifying. So if you want to modify or set an element of an array, then you use this syntax. You say the name of the array, the index that you want to mess with, and then give it a new value. So this is a lot like assigning a variable. You know, variables go var name and then equals value. The only thing different now is that, the only thing different now is that we have to say which index. Do we want to change the thing in the first index or the second index or the third or so forth, okay? So that's the difference between assigning or modifying elements of an array. So for example, say we built an array of strings, and I had space for 5 strings. Well, what does that look like? It looks like this. We have an array that's called names. This is my name of the array, and we've got 5 items in it. So 0, 0, 1, 2, 3, 4. That's going to be 5 items, and they're all initialized to null, right? That's what happens first for arrays of objects or arrays of strings. Names 0 equals Alfred. So if I write this line of code after initializing the list of strings, the array, then what we're going to do is we're going to put Alfred into the element. Alfred is going to become the element at index 0. So that index matches up with the location of the element that we're changing, right? So now Alfred is stored in the first box. And so if I now say names1 equals Bruce, then that's going to change the thing in the second box, right? So now Bruce is stored in index 1. If I said names2 equals Gordon, then that's going to change Gordon, the thing in the second at position 2, so the third box, to Gordon. And so this would be my array now after doing this. Now could you also do names 4? Names 4 equals, say, give me another Batman hero. Let's say we'll just Robin. I think his name is Dick Grayson, but I can't remember exactly. I was looking this up the other day. So if you said names 4 equals Robin, then that would give us Robin over here. And null would be 3. 3 would still be null. So that's fine. It's okay for us to skip. We don't have to go in sequential order. I was just doing it in sequential order to make it easier on us. Okay? So you can access any one at any time. It doesn't have to be in sequence. To access a specific element of an array, then you're going to use the name of the array and then the index, and that's going to give you back the value that's stored in that location. So, for example, my array is that array from earlier, Alfred, Bruce, Gordon, null, null. Then if I were to print out names bracket 0, I put a println and names bracket 0 inside of it. That's going to print out whatever is stored at index 0. And so that's Alfred in this case. And if I were to print out the thing that's stored at position 3, at index 3, well, there's no object there, and when you have null and you print that out, it prints null. It just prints the text null. Now remember, that's not a string, it's actually no object. So there's nothing there at position 3. And if you printed out position 2, you get Gordon, position 1, you get Bruce, and so forth. Okay. So common error. Attempting to access an element at an invalid index is an error and will throw an array index out of bounds exception. So if you see this word pop up in a bunch of red text and your program quits, don't freak out. That's kind of a good thing. It means you have an error in your program and you need to go and figure out what the error is. This means that you're trying to access something that's either an index that's either more than the last index or less than the first index. So for example, if I make an array, double grades equals new double 10, so I'm going to store 10 grades in a list. My valid indices are from 0 to 9. So I can do grades 0, I could do grades 1, all the way up through 9. If I tried to do grades 10, that won't be valid or higher, okay? So if I tried to access the thing at index -1 and I said make that 4.0, for example, this throws an error because -1 is not a valid index. Indices have to be 0 or more. If I try to access the thing at index 10, that throws an error as well. Both of these throw array index out of bounds exceptions because 10 is more than the index of the last element. The index of the last element is 9, remember? It's always one less than the length. So our valid indexes are 0 to 9, -1 is out of bounds, so this is bad. 10 is out of bounds, that's bad as well. You could only put numbers that are between 0 and 9 in the brackets there. Okay, our last thing in this video I want to mention is that arrays have a special initializer that you can use when you create an array for the first time. You can declare an initialized array to a list of values if you know what the values you want to be right off the bat. So if I knew that I had a bunch of temperatures from some website and I wanted to put them all into a list and I knew what they were, then I could use this syntax to initialize my array so that I don't have to go through one at a time giving each thing a value because they get initialized to 0 automatically, right? And so, for example, say I have all these temperatures, I'm keeping track of my temperature in the morning and I want to just add a new temperature on to the end of my list each day because I have a fever. You know, my first day temperature was 98.6, my next day was 99.1, and then I had a 101.0 temperature, and then 100.4, 99.2, and 98.6. So we can see this list of temps. You know, if I wanted to add another one to this, I could put a comma and then another value on the end. What this would do, this line of code, what it would create space for, let's count them up, 1, 2, 3, 4, 5, 6 items. So there's 6 items in my list. They would be at position 0, 1, 2, 3, 4, and 5, right? So Java knows that you want to put this in the order that you write it. So 98.6 is the first thing in the list, and that's going to go at position 0. And because it can count how many items you have, how many items you have in a row, it's going to give you the size of the list that you want it to be. Now, if I wanted to add on to this list, I could only do that in the initializer. I couldn't do it later once I've created the list. So I couldn't add a new item to the end of this. Because remember, once you've made an array, you can't change its size. It's always going to be the same size. Okay, so that was a bunch about arrays, and we'll get some practice working with them later on this week. And hopefully they won't feel too different from working with strings, because you're going to be doing a lot of the same things, looping over each item in the array and doing some stuff with it. Okay, so for loops and arrays really go well together, just like for loops and strings really go well together. Okay, I will see you guys in class tomorrow. Adios.